Good morning, students. Welcome back to the chemistry class. I hope you all are safe and sound at your home and taking good care of yourself. Today, I will continue with the same chapter number 4, that is atomic structure. Now we will study the periodic table. Towards the end of 18th century and in the beginning of 19th century, the number of elements went on increasing. It became difficult to study and remember the properties of these elements. Students, in the daily life also, when there are many things that need to be studied and examined, it is obvious to make the process simpler. Therefore, over the passage of time, when many more elements were discovered, there was a need to organize and classify these elements in order to make the study of the elements easier and simpler. Students, what is periodic table? Periodic table is a table or a chart in which all the known elements are arranged in the vertical columns and horizontal rows. So how many vertical columns are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 vertical columns are there. So these are known as groups. How many groups are there? 18 groups are there. Okay. And the horizontal rows from left to right, these are known as the horizontal rows. How many horizontal rows are there? 1, 2, 3, 4, 5, 6, 7. So total 7 horizontal rows are there from left to right. So these horizontal rows are known as the periods. So how many groups and periods are there in the modern periodic table? There are 18 groups. Okay, and there are 7 periods. Now these two series, okay, the first series is known as the lanthanide series. This one is a lanthanide series. It belongs to the 6th period. That's why the number 6 is written over here. And the second series, this is for the actinides elements. Okay, so this is coming in the 7th period. So total, how many periods are there? 7 periods, including lanthanide as well as the actinide series. Let us see how the elements are arranged in the periodic table. Okay, so elements are shown in the periodic table with the help of their short form, that is the symbols. Like first is H. H is a symbol for the hydrogen. He, the symbol for the helium. Li, the symbol for the lithium. Be is a symbol for the beryllium. B is a symbol for the boron. C is a symbol for the carbon, and so on. So all the elements are shown with their symbols in the periodic table. Okay. Periodic table shows a lot of information about the element. It shows first of all the symbol of the element, as well as the name of the element is written at the bottom. For example, Al is a symbol for aluminium. So Al symbol is written as well as the name of the element is given. Si is a symbol for silicon. So Si symbol as well as the name of the element is given. Now apart from this, it is showing one number also. On the top, H given 1 number, helium given 2 number, lithium is given 3 number, beryllium given 4 number, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, and so on. These numbers on the top of the symbols represents their atomic number. So hydrogen has atomic number 1, helium has atomic number 2, lithium has atomic number 3, beryllium has atomic number 4, boron has atomic number 5, carbon has atomic number 6, nitrogen atomic number 7, and so on. If I talk about magnesium, its atomic number is 12. So atomic number is shown on top of the symbol in the periodic table. As we know, atomic number is number of the protons. If we talk about these neutral atoms of the elements, they are neutral atoms because they don't carry any charge on them. They are not showing positive charge or a negative charge on them. Hence, these atoms are all neutral atoms. So, this atomic number is equal to number of the protons equals to number of the electrons. Therefore, if I talk about carbon, 6. 6 is the atomic number for the carbon. So, number of protons also becomes 6. Number of electrons becomes 6. If I talk about phosphorus, 15 is the atomic number. So, number of the protons are 15 and number of electrons also 15. Sodium, its atomic number is 11. Number of protons becomes 11. Number of electrons also becomes 11 for the neutral atom. So, the periodic table showing the symbol, name of the element, atomic number. It shows the structure of the atoms also, whether the structure is cubic or hexagonal or crystal, etc. Nature of the element, whether they are metals or whether they are non-metals or metalloids, halogens or the noble gases. So nature of the elements also is shown by the periodic table. It shows the atomic weight of each atom, the melting point as well as the boiling point. Hence, we can say the periodic table shows a lot of information about the elements. It is very important because it organizes all the elements in a very simple and a systematic manner. So, in the modern periodic table, elements are arranged in a very organized manner. So, the elements with the similar properties are grouped together in the same vertical columns or the same groups. For example, all the elements of group number 1 like lithium, sodium, potassium, rubidium, cesium, francium, apart from hydrogen, they are having the similar properties. Group number 2, all the elements of this group have the similar properties like beryllium, magnesium, calcium, strontium, barium and radon. So we can say the elements with the similar properties are grouped together in the same vertical columns or the same vertical groups, and dissimilar elements, they are separated from each other, means dissimilar atoms are placed in the other groups. So what is the use of the group number? What is the use of the group number? The group number of the periodic table is used to write down the electronic configuration of the atom, to calculate the valence electrons and the valency of the atom. I repeat again, these group numbers help in calculating the valence electrons and valency of the atom, as well as they help in writing down the electronic configuration. Children, we will understand and learn these topics one by one. So what is the significance of periodic table? Periodic table is the most powerful tool for the chemist to organize the elements in a very simple manner. It systemizes the study of the elements. It makes the study of elements very simple and easy. It helps in studying the properties of the elements and relating the properties of the elements with the other elements. And we can learn the relationship between the different elements with the help of the properties which are shown in the periodic table. Students, with the help of an example, let us understand orbits, electronic configuration, valence shell and valence electrons. This is a symbol Al. The symbol is for aluminium. What is its atomic number? 13 is the atomic number and 26 is the mass number. So we'll write here atomic number is 13, right? Mass number is 26. Number of the neutrons. Number of neutrons is mass number minus the atomic number. So 26 minus 13. How much? It is 13 number of neutrons. Number of the protons. Atomic number equals to number of protons, which is equal to number of the electrons for the neutral atom without any charge on it, right? So number of protons equals to the atomic number, that is 13. Number of the electrons also becomes 13. Okay. Now we will write in the nucleus protons. How many protons? 13. And neutrons also, they are 13. Okay. Now let's distribute these electrons in the energy shells or the orbits. Okay. So we know the closest shell to the nucleus is the first shell, that is known as a K shell. So this is a K shell, right? The second shell is L shell and the third shell is the M shell. Fourth will be N, but we will show only 3 shells over here for the aluminium. The first shell, which is nearest to the nucleus, is the K shell. The electrons are strongly attracted to the nucleus and this K shell can hold up to 2 electrons. So 13 minus 2 electrons. How many electrons left? 11 electrons. So 2 electrons will go in the K shell. How many left? 11 electrons are left. We know the second shell, that is the L shell, can hold up to 8 electrons. So we will distribute the 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8. So 8 electrons are arranged in the second orbit. Okay. So 2 electrons in K shell and 8 electrons in the L shell. So how many electrons are now in the shells? 2 plus 8, 10 electrons are already arranged in the 2 shells K and L shell. So how many are left now? 13 minus 10 electrons, 3 electrons are left. So the last shell, the M shell, will have 3 electrons. 1, 2 and 3. So how many shells are there in the aluminium? 1, 2, 3. 3 shells are there. K, L and M. And what is the electron arrangement in these orbits? 2 electrons in the K shell, 8 electrons in the L shell and 3 electrons in the third or the last shell. So electronic configuration will be 2, 8, 3. Okay. So this is the electronic configuration for the aluminium. So if we try to add them together, 2 electrons plus 8 electrons, 10 electrons. 10 electrons plus 3 electrons, 13 electrons are distributed in this atom. And number of the electrons in the aluminium atom is 13. Hence it is correct. So what is orbit? Or what are electron shells? The electrons revolve around the nucleus in definite energy shells, which are known as the orbits. Okay children, the electrons revolve around the nucleus in definite energy shells, which are known as the orbits. So K is an orbit, L is an orbit, M is an orbit, N is an orbit and so on. These are the definite energy shells which are known as the orbits. Let's look at the definition. The electrons revolve around the nucleus in definite energy shells which are known as orbits. Okay students? What is electronic configuration? What is it telling us? It is telling us the arrangement of the electrons in various orbits. or in various shells, how many electrons are arranged. So, electronic configuration is the arrangement in which the electrons arrange themselves in various orbits, or the various electron shells is known as electronic configuration. So let's have a look at the definition. The arrangement in which electrons arrange themselves in various orbits or various energy shells is known as electronic configuration. So electronic configuration is 283, okay, for the aluminium atom. Students, what are these? These are the energy shells. K shell, L shell, M shell, or you can say these are the orbits. So, what is valence shell? See, which is the last shell in the aluminium atom? M. M shell is the last shell in the aluminium atom. So, the last shell is known as the valence shell. So, in aluminium, which is the valence shell? M shell, or the third shell is the valence shell. As we can see in aluminium, the last 3 electrons have gone to the last shell, which is the M shell. So, M shell becomes its valence shell. So, we can define valence shell as the last shell of the atom. Children, how many electrons are present in the valence shell? Which is the valence shell in aluminium atom? M shell is the valence shell, or the last shell in the aluminium atom. How many electrons are present in this shell? 3 electrons are present in the valence shell. So, what are valence electrons? Valence electrons are the electrons present in the valence shell of the atom. So, how many valence electrons is aluminium having? Aluminium has 3 valence electrons, as those 3 electrons are present in the valence shell of the atom. Is it clear? Let's see the definition. Valence electrons, the electrons present in the valence shell or the last shell, are known as the valence electrons. Students, let us discuss few rules to write the electronic configuration of the first 20 elements. You need to understand and learn the electronic configuration of the elements from atomic number 1 to atomic number 20 in the periodic table. Means from hydrogen to calcium, you need to learn the atomic numbers, as well as you need to understand their electronic configurations. The first shell is a K shell. It has 2 electrons, means maximum it can hold up to 2 electrons, and it has the minimum energy. The next shell is the L shell, which is at slightly higher energy than the K shell, and it can have maximum 8 electrons. The third shell, that is the M shell, is having more energy than the L shell, and it can accommodate 8 electrons. The last shell is the N shell, and it has a maximum energy compared to the other shells K, L, M, right? So maximum energy is of the N shell, and it can hold up to 2 electrons till atomic number 20. Okay, children? Now, unless the lower energy levels like K, L, etc. are completely filled, electrons cannot move to the higher energy levels. For example, if the K shell is not completely filled, electrons cannot move to the L shell. If L shell is not filled with complete 8 electrons, the electrons cannot jump to the M shell. So, the previous energy shells should be complete with the maximum electrons, then only the rest of the electrons will be going to the higher shells. Let's do one example. This is Ca is a symbol for the calcium atom. So calcium atomic number is 20, mass number is 40. So atomic number is 20 and mass number is 40. Okay. Number of the protons will be equal to the atomic number, that is 20. Number of the protons equals to number of the electrons in the neutral calcium atom. So number of protons is 20, number of electrons also 20, right? Number of the neutrons. Number of the neutrons will be mass number minus the atomic number. So 40 minus 20, that is mass number minus the atomic number 40 minus 20, that is 20 neutrons. Okay. Now we will write in the nucleus protons 20, neutrons how many? 20. Now let's see the electronic configuration, the electron distribution in the various orbits or the various energy shells. So first shell is known as the K shell, second is the L, and then third M, and the fourth shell is the N shell. So total how many shells calcium atom is having? 4 shells or 4 orbits calcium atom is having. Okay. Now the first K shell has the 2 electrons in it. So 1 and 2. 2 electrons are revolving in the first shell. The second shell is the L shell. It can accumulate maximum 8 electrons. So 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons are revolving in the second shell, that is the L shell. Now is the M shell. 2 electrons in K shell, 8 electrons in the L shell. To total 10 electrons are already arranged. How many are left? Total number of the electrons are 20. So 20 minus 10, 10 electrons are left now. So M shell, as per the Niels Bohr, he said it can accumulate 18 electrons. But if I put all the remaining 10 electrons of the calcium atom in the third shell, that is the M shell, then M shell will become the last shell or the valence shell of the calcium atom. Right? Calcium atom will not require the fourth shell, that is the N shell, for the electrons then. But this is not valid in chemistry. The valence shell or the last shell of an atom cannot take more than 8 electrons, even if it has a capacity to accommodate more electrons. It means the outermost shell or the valence shell of chemically stable atom can accommodate a maximum of 8 electrons only, not more than that. Okay, for stability the atom needs 8 electrons. So the maximum capacity of M shell is 18, but only 8 electrons are filled in the third shell. The remaining 2 electrons will go in the N shell. So M shell will have how many? It will have the 8 electrons, 3, 4, 5, 6, 7, 8. So 8 electrons in the M shell and remaining 2 electrons in the N shell. So total will be 2, 8, 8, 2. How many electrons? It will be 20 electrons. The total number of the electrons in calcium atom is also 20. So what will be its electronic configuration? It will be 2, 8, 8, 2. 2 electrons in K shell, 8 electrons in the L shell, 8 electrons in the M shell, and the last 2 electrons in the N shell. So this is the electronic configuration for the calcium atom. And what is the valence shell in this? N shell. The last N shell is the valence shell for the calcium atom. And how many valence electrons are there? There are 2 valence electrons in the calcium atom, means electrons which are present in the valence shell. How many electrons are present? 2 electrons. So these are the valence electrons. Okay, children? This is a note. The outermost shell of an atom cannot accommodate more than 8 electrons. Which shell? The valence shell. It is because the atom becomes stable only after requiring 8 electrons in the outermost shell. Therefore, the outermost shell of a chemically stable atom can accommodate a maximum of 8 electrons. Okay, when it acquires 8 electrons, then it is stable.